Hi guys, welcome to the first part of a little mini series, two-part series on adding and subtracting random variables. If you missed the videos on constants or already watched, um, this will follow the same manner as those. And I'm going to jump right into it. So I realized when I was doing it earlier that I didn't like how I was presenting, so I have to refilm it. But we're given that we have a distribution of x in purple where there's an expected value of 1 and a standard deviation of 3, and a distribution of y in light green, which has an expected value of 2 and a standard deviation of 4. And we want to add x and y together, which means we want to find the expected value of x plus y and the standard deviation of x plus y. So I've already written some stuff down, and I'm just going to walk you through it. Let's consider that X and Y are lottery games or lottery winnings, or well, maybe not lottery games, casino games, and our expected values is how much we win from those games. So if we play casino game X, we would expect to win $1, and if we play casino game Y, we would expect to pay $2. When we add those together, our expected value of X plus Y is basically saying, what if we played both games? And so you would naturally say, if I told you you're going to probably win $1 from this game and probably $2 from that game, what would you win with both of them? You guys would say 3. And that would be absolutely correct, because all you're doing is you're saying that the expected value of the two games together is just their expected values individually added together, which is e of x plus e of y. We substitute those numbers in. We get 1 plus 2, which is our expected values here, and we get 3, which is what you guys naturally would suggest, and which I'm sure you guys don't even need a formula for. The tricky part now is standard deviation, finding the standard deviation. And this comes as a little bit of a twist compared to what we were doing with constants and stuff. So when we're adding random variables, we need to be very careful when we're calculating standard deviation. You can kind of think of it as a Pythagorean theorem. So we would say that the standard deviation of x is 3. So we have a distance of 3 here. Our standard deviation of y is 4. And so we naturally want to find the standard deviation of them together, which is this distance. So they went 3 this way and 4 up. We want to know what this is. And so your Pythagorean theorem looks like this. A squared plus b squared equals c squared. In this case, our a can be 3, our b squared can be 4. We need to find c squared. You'll notice that our variance equation for adding random variables together looks kind of the same way. So we would want to write that the variance of x, our variance squared, so we have our variance, our standard deviation squared is our variance, really. And then we have our standard deviation squared of y, which is what we have right here, equals our standard deviation squared of x plus y. Which means that we can kind of use this, you should be able to see that all these squareds work together. So this is just like solving a Pythagorean theorem, basically. So we know that our first side length is 3. Our second side length is 4. And so that means that if we plug these in, we get our first side length is 3. So we get the standard deviation squared, which is the variance, is 3 squared. Then we're going to plus our standard deviation squared of y is going to be 4 squared equals, we want to find the variance of x plus y first. So we do this, we find that 3 squared is 9, 4 squared is 16, and that is equal to our variance of x plus y, our standard deviation squared of x plus y. Variance, remember, is just the standard deviation squared, so that's why I'm using them interchangeably. When we add these two together, we get 25 equals our variance. And since we want to know the square root of that, just the regular standard deviation, we're just going to square root both sides. So we just get square root of 25 equals standard deviation of x plus y. You guys should know that the square root of 25 is just equal to 5. So that's a little bit more complex. You can also find the standard deviation of x plus y by using this formula, which is just a condensation of it. And basically what it's saying is the standard deviation of x plus y is the square root of the variance of x plus the variance of y. If that's easier for you to remember than trying to compare it to the Pythagorean theorem, that's okay, whichever way works, but you guys need to remember that in this one it's not as straightforward as just adding their standard deviations together. We need to add their variances together first and then take the square root of it. So we add variances and take the square root to find our standard deviation of x plus y. So that is all for adding. It might have been a little confusing in the middle there. I'm sorry about that. It's a little hard to compare them together. But I hope that you guys at least get this somewhat. You guys can always reference your book. But the standard deviation is the hardest part. Just remember that the standard deviation of x plus y is the square root of the variances added together.